Okay guys, one more video for today. This is probably the hardest reaction in this chapter to think about. So this is called the Robinson annulation. What an annulation is a reaction that forms a ring, and every Robinson annulation will always form a six-membered ring with an alpha-beta unsaturated ketone in it. That will always be the product of a Robinson annulation. The way we get this is always going to be reacting a ketone substrate with an alpha-beta unsaturated ketone in the presence of a weak base like sodium hydroxide. So I went through the mechanism for how this works in your notes, but let's talk through it quickly here. So the reaction is going to start out by having the weak base hydroxide generate a small amount of enolate from acetone. And so what we will get from that is a nucleophile that can then react with the alpha-beta unsaturated ketone in a Michael reaction, which we just talked about in the previous video. So the enolate will collapse down, use its electrons at the alpha carbon to attack the beta carbon of the alpha-beta unsaturated ketone, and those electrons will flow towards the carbonyl of the alpha-beta unsaturated ketone. That sequence of events forms a new bond between the alpha carbon and the beta carbon of the alpha-beta unsaturated ketone that got attacked. And so what we have formed now is a new enolate that looks like this. And so now that material can react to form the neutral Michael product by picking up a proton from water. And so that enolate will collapse down and grab that proton off of water. And what we'll get out of that is the initial product along the way to the Robinson annulation product. We have formed a Michael product. If you think about what has to happen next, the Robinson annulation is a Michael reaction followed by an aldol reaction. And so what will end up happening now is, if we count carefully from the other alpha carbon, we can count 1, 2, 3, 4, 5, 6 atoms away. We find the carbonyl of the starting ketone. And so what ends up happening next to finish out this reaction is that the other alpha hydrogen on the other side of the alpha-beta unsaturated substrate will be deprotonated to form an enolate. That will give us this product, where we've generated the enolate on the other side. Now what can end up happening is this enolate will collapse down and undergo an intramolecular aldol condensation to form a six-membered ring. Again, we can count 1, 2, 3, 4, 5, 6 atoms away. And so that's going to snap this ring shut into a system that looks like this. And so this bond is the one that we formed in this intramolecular aldol reaction. This alkoxide that we formed will protonate with water. That will give me what looks like a normal aldol product. And that material then reacts with hydroxide to do an elimination to form that alpha-beta unsaturated product by means of losing water. And so that takes us through all of the sequences that give us the Robinson annulation product. It's again to review, it's a Michael reaction between an enolate and an alpha-beta unsaturated ketone to make a Michael product. That Michael product then undergoes an intramolecular aldol condensation to give you this six-membered ring. What I want to talk about next at the very end of this video is how to take a look at a Robinson product and predict what starting materials it came from. So let me give you a quick tutorial about how to do that. So if we come up with just any generic Robinson product, so it's always going to be a six-membered ring that has a double bond in it. Now let me add a few extra things to it just to give you a sense of how we can pick out where the product which things came together to make this Robinson annulation product. So these are easy to solve if you carefully label the product. So every Robinson annulation product is going to have a 6-membered ring with an alpha beta unsaturated carbonyl. What you need to do is find the side of that system that does not contain the double bond, and we're going to label through the ring the alpha, the beta, and the gamma carbon. Okay? What we're going to do next to do this analysis is we're going to cut this 6-membered ring in half by dividing through the carbon-carbon double bond of the product and the beta-gamma bond. So we're going to cut this in this way. And so if we cut it in this way, what we're looking at on the bottom of this cut is the carbonyl species that we used to make the Robinson product. We used this ketone, and the top portion, conveniently labeled already alpha and beta, are going to be all of the carbons that came together from the alpha beta unsaturated starting material. And so everything else just comes by hanging the substituents off of those pieces. So a Robinson annulation between these two materials would give us that product. So we get that by, again, labeling the alpha beta gamma carbons of the saturated side of the product, and then cutting that product through the alpha beta, through the carbon double bond and the beta gamma carbon.